Good day to all of you. My name is Juaneza, and today I will be presenting my statistical analysis for MATH6200 Data Analysis course project. Before we start, I would like to present the data provided and also the questions that are needed to be answered. As you can see, there are three variables presented on the table: sex, sleep quality, and job performance. They are also grouped according to the sex. We have female group and male group. The numbers vary according to each respondent. So here are the questions. Letter A, is there a significant relationship between insomnia and job performance of the respondents? Letter B, is there a significant difference in the level of sleep quality when they group according to sex? And letter C, is there a significant difference in the level of job performance when they group according to sex? So in addition, this will be the scoring guide for the level of insomnia and job performance. So for sleep quality scoring guide, 0 to 7, no clinical significant insomnia; 8 to 14, sub-threshold insomnia; 15 to 21, clinical insomnia or moderate severity; 22 to 28, clinical insomnia severe. So job performance scoring guide, 0 to 20, fail; 21 to 40, not good; 41 to 60, meet the expectation; and 61 to 80, exceed the expectation. Let's take a look at the first problem. Is there a significant relationship between insomnia and job performance of the respondents? To solve the problem, I provided 3 steps below. The first one is the testing the hypothesis, to be followed by the application of statistical tool, and lastly will be the drawing of conclusion. So for hypothesis testing, it is used to determine if the correlation is statistically significant. These are the null and alternative hypothesis. So for the null hypothesis, there is no significant relationship between insomnia and job performance if the p-value is equal to 0. And for the alternative hypothesis, there is a significant relationship between insomnia and job performance if p is not equal to 0. So to test this hypothesis, we will use a statistical test such as the Pearson correlation test. The test will provide a p-value which will help us to determine if the relationship is statistically significant. But first, what is a Pearson correlation test? A Pearson correlation is a statistical test to determine the association between two continuous variables. So the output is given as that is given as the Pearson correlation coefficient, or R, which is a value ranging from -1 to 1 to indicate the strength of the association. So in Excel, there is a function available to calculate the Pearson correlation coefficient. So to calculate the Pearson correlation coefficient, we will use this function, equals Pearson RA1, RA2. Then, calculate the t-statistics from the coefficient value. The formula is R times square root of n minus 2 all over square root of 1 minus R squared. But if we get a negative coefficient from the first step, we will use this function, this formula, equals to absolute value of R times square root of n minus 2 all over square root of 1 minus absolute value of R squared. So to determine the n, use count function. To determine the degrees of freedom, use the formula n minus 2. And lastly, calculate the p-value from the t-statistic and t-statistic using the t-dist function in Excel. So before we proceed to the calculations, I have pre-plotted the data to a scatter plot. So here is the scatter plot. Here you can see a slightly downward trend in the scatter plot. So we can now open the Excel and compute for the correlation coefficient, t-statistics, and the p-value. So for a while, So here, we have two groups for the sleep quality and job performance. As you can see on the data, I have grouped them according to their respective category. So first, we need to determine the R or the coefficient. To do this, we will use the Pearson function in Excel. So equals Pearson, open parenthesis, RA1, sleep quality, comma, then the RA2, the job performance. So close parenthesis, then hit enter. Now, we have the value of negative 0.17, which indicates a negative correlation between the two variables. Hence, the downward trend is shown on our scatter plot, as you can see. The next is to get the value of n using the count function. So what is n? N is the number of pairs in the test. So we use the count function equals count equal sign plus count, then open parenthesis, then choose an array of 31. So we have 30 pairs in this set. Then we can determine the t statistic. Since we have a negative 0.17, negative r, we will use the formula that has a absolute value on the formula. So equals sign, open parenthesis, absolute value of r times the square root of n minus 2 all over this, open parenthesis again, the square root of 1 minus absolute value of r squared. So now we have a value of 0.91 for the t statistics. Then next is to determine the degrees of freedom or DF. So to determine the DF, we have to subtract the n minus 2. Finally, we can determine the p-value using the t-dist formula. So t-dist, for x is t statistic. So this one, then df, the degree freedom, then tail, 2. So we have the value we have the p-value 0.368084 or 0.37. So we close this one. The correlation of negative 0.17 indicates negative correlation between between the two variables. As shown in the scatter plot, as the level of insomnia increases, the job performance is somewhat decreases. But the strength of this relationship is weak because the correlation coefficient is close to 0. The correlation is weak and the p-value suggests that the observed correlation could be a result of random variation. So the p-value of 0.36 is relatively high, which indicates that the relationship between the two variables is statistically significant. Okay, the next problem is to whether there is a significant difference in the level of sleep quality when respondents are grouped according to sex. So applying the steps we have used earlier, we will now formulate our hypothesis. For the null hypothesis, there is no significant difference in the level of sleep quality between females and males if the p-value is greater than or equal to 0.05. And for alternative hypothesis, there is a significant difference in the level of sleep quality between females and males if the p-value is less than to 0.05. For the next procedure, we will use a statistical tool called the independent sample t-test. This test is appropriate for comparing the means of two independent groups, in this case, comparing the sleep quality scores of males and the females. So the first one is to calculate the mean and the standard deviation for each sex. Number 2 is use independent sample t-test, where we calculate the p-value using this formula, t.test, RA1, RA2, tails, and the type. Compare the mean of the two groups and check the p-value if it is p less than to 0.05 or p is greater than or equal to 0.05. But before we proceed to the computation, I have a bar chart that shows a graphical presentation of the level of sleep quality on each group. I have grouped them according to the given scoring guide earlier. So here's the sleep quality scoring guide. So we now open the Excel to compute for the p-value. First, we need to determine the mean and the standard deviation on each gender. So for the mean, we can use the average function. So average, RA1. Then for the female also, average. As you can see, the mean of the two groups have a statistically significantly different on one another. So for the standard deviation, we can use the stdev.s function. So stdev.s for the male and for the female. stdev.s for the female. Okay. Now, we can determine the p-value, and we will use the t-test function. So t.test says here RA1, so male, RA2, female, and tails is two-tailed, and the type is 2. So we have a 0.009656674, or if we round it off, we will have a p-value of 0.0097, which indicates that it is less than 0.05. So we can close this for the meantime. The means of male and female have a statistically significantly different on one another. This indicates that the quality of sleep for the males are significantly higher or better than the females. Thus, we have a p-value that is less than the significance level. We can reject the null hypothesis and conclude that there is a significant difference in sleep quality between the male and female groups. Having the mean of 20.61, which is the level of insomnia, indicates that females are suffering a severe clinical insomnia than the 14.92 of the males. So down to the last problem, here's the question. This should be a problem number 3. Is there a significant difference in the level of job performance when they group according to sex? We'll also use the same process we've done from problem number 2. So let's set up first the hypothesis. So for the null hypothesis, there is no significant difference in the level of job performance between females and male if the p-value is 0.05 or 0.05. And for alternative hypothesis, there is a significant difference in the level of job performance between females and males if the p-value is less than 0.05. So for the statistical tool, we will also be using independent sample t-test. Okay, the number 1, calculate the mean and standard deviation for each sex. Use independent sample t-test, calculate the p-value using this formula, and lastly is to compare the mean of the two groups and check if the p-value is greater than or equal to 0.05 or less than to 0.05. So before we proceed to the computation, I have here again a bar chart that shows a graphical presentation of the level of job performance on each group. As you can see, the job performance of the males tend to reflect only at the range of 61 to 80, which exceeds the expectation according to the job performance scoring guide. And for the females, there are 4 who fell at the range of 41 to 60. So we will now open the Excel. Okay, again, we have to determine the mean and the standard deviation in each group. So we use again the average function for the male and also for the female. For the standard deviation, we use the stdev.s function again. And for the female, stdev.s. Now we have to determine the p-value also. So we use the t-test. T-test, RA1, then RA2. Then for the tails, 2 tail again, then 2. Now we have a p-value of 0.046250004. If we have to round it off to the two decimal values, we have a 0.05, right? 0.05 p-value. So we close this one for the meantime. And for the conclusion, the p-value is somewhat equal to 0.05 alpha level. Then we conclude that there is no evidence of statistical significance on the levels of performance between males and females. Thus, failing to reject our null hypothesis, there is no significant difference in the level of job performance between females and males. But somehow, you can see the value of mean for males is higher than the females. You can see here. Is it because of what we have tackled earlier regarding with the level of insomnia, right? So for the summary, as you can see from the data, there are 4 females who suffer really high insomnia level. As you can see, it is highlighted. They are highlighted in black. The 4 females, which obviously also fall off the range of 41 to 60. Here it is for the job performance level. In conclusion, this group of women are lack of sleep than the group of men, which results of some females render their job in the meet the expectation range. So this is the end of my presentation and thank you for watching.